Hi everyone, my name is Paula Pardo. I'm tech evangelist and co-founder at Qbeast, and today I'm gonna introduce you to the Qbeast Spark project. Just a little bit of how the project is built, the different components of the project, classes, code reviews, whatever. Just a little bit introductory because it's a huge project and you could get lost easily, but it's kind of nice to meet you guys. So basically, Qbeast Spark. What is Qbeast Spark for those who are new to this? Um, it's an extension for data lakehouses such as Delta, Iceberg, and Huri that enables multidimensional filtering and sampling at the same time. So we're basically constructing an index with your files. We're saving each file will belong to a range of dimensions, let's say, and on these files will contain a representative sample of the data. So for instance, how this works and how you can use it. So for instance, if you want to search for the uses that you have on Barcelona and age around 20, you don't really need to load the data from the different points in the world, from the different ages. You only need to reach to that certain amount of records. So that you can do with multidimensional filtering, multidimensional indexing. And the sampling part, it's basically that we don't need to sample reading all the data. We just know where the sample is stored, in which files is that percentage of data. And why is sampling so important? Because if you want to calculate an aggregate of the data, for instance, let's say the average price that you use are expending, you can approximate the result. You don't need to load all the data because that aggregate, you don't need to calculate it at the exact precision. So with the margin of error, you can read a sample of data with Qbeast and you can output an approximate aggregate. So you will have an idea of how much your customers are expending just at a fraction of the cost. This is super fucking cool, but how you can contribute? I want to contribute to everything. How can I contribute to the project? So we're basically an open source project, so we're open to any suggestions. But I know this is a complex project. There's a lot of layers on this project, and one can get super lost. So I'm here to explain you what are the different packages, what are the classes or the main objects from the different packages, and how you can interact with them. And first of all, I will say that it's designed in a way that it's pluggable for different technologies. Let me explain this. So as you can see, it's Qbeast Spark. So its first implementation, it's for Spark. So you can read and write with on the Qbeast format with Spark, but it can be pluggable with different query engines that may appear in the future. And also, it's the first implementation is built for Data Lake, but that doesn't mean that it's only suitable for Data Lake. So we're planning to integrate also with Iceberg, with Huri, with whatever format comes in the next years. So we're kind of in the middle. So we are integrable with any other source. We are designed for this, not yet there, but we're designed for this, and we're like not hoping, but it will be so great that anyone that wants to also be part of this and build these connectors for other sources, it's more than welcome. So we are open to anyone that may contribute and may have like a greater knowledge on these technologies and want to also use Qbeast in their stack. So first of all, what is this project about? Not about, but what is this project language? What are the components or the packages of this project? Because this is a huge project. So how we can separate it through modules, for instance. So it's a Scala project, build a CBT, whatever. And we have two main modules or two main packages here. One is the Qbeast core, the Qbeast core contains like all the interfaces that are only about Qbeast. So only classes and interfaces of Qbeast without any other dependencies such as Spark, such as whatever engine you decide to use. And the Qbeast Spark, it's the one that it's based only for Spark. So let's start with the Qbeast core. No, let's start with which interfaces are only for Qbeast. Let's see. On the main, we have core package. We have 3 different packages inside the core. We have the keeper, the model, and the transformation. The model, I'm gonna dig into the biggest ones. The model will contain all the interfaces that we talk about, no? And which interfaces are those, or how its Qbeast is designed to be that integrable between all the different technologies and services. So we have basically decoupled the way we write and the way the metadata is managed and the way the index is managed. So we can also even have different algorithms for indexing. So let's start with, let's say, maybe the context. Okay, the core context. So which ones are those components that make Qbeast Qbeast? So we have, for instance, the metadata manager. The metadata manager is the one in charge of committing the information to the log. So let's just recap just a little bit. So if you're not familiar with Lakehouse is basically adding ACID transactions to ACID properties, transactional properties, to the lake. So for these transactional properties to happen, they store like a log, each one of them, like Delta, Iceberg, and Hood. They store a log with every transaction that has happened onto this table, and from the very beginning to the nowadays. And this transaction does have certain metadata. So the process in charge of committing information to this transactions log will be called metadata manager. So this metadata manager can be implemented from the different formats. So Delta will have their own data manager because they have their own way to manage metadata. Iceberg will have their own, etc., etc. The data writer is exactly the one that it's basically writing those files down. So this process can belong to different query engines. So now it will be a Spark, but then it could be translated to maybe another Rust query engine that may appear in the future, RFusion, some kind of that. So the data writer it's the one in charge to getting this data and writing it down to the files. The index manager is the one that takes the data and indexes the data. So indexing it just by saying this record belongs to that space and had this weight. So the weight is what we use to actually determine afterwards the percentage of data that these files contain. So this is the index manager. Then we have the query manager. The query manager is not yet implemented. It's supposed to be also decoupled for the engine that you use to query, but right now it's like in a stale mode. Revision builder. So revision is mainly the scope of your operation, let's say. So if you want to index data from 0 to 1, and then later on you will index data from 2 to 3, this data will belong to different revision. This concept of revision may be changed in the future, but it's a self-contained index. So each revision will contain a version of an index, and when we query these revisions, we will have to retrieve information from each of them. So as many revisions as we have, worse, but we can try to reduce the amount of revisions that we do, or try to put certain policies to make, if you like create 10 different revisions to compact them into a single one, that will be another strategy. So what can we say about each one of them? So for instance, there you have the different, there are traits, there are interfaces where you will have like the methods that you have to extend, and these objects or types here are for will be different for each of the implementations. So for instance, in the data writer, we will need the data. So for a Spark, it will be the data frame. We will have a type for the data schema. For a Spark, it will be the struct type, and a type for the file descriptor. The file descriptor will be the end result of this. So we will return a sequence of files that we write. The methods of the data writer are obviously write. So giving a table ID with this schema, with this data, and with these table changes, we will write, we will return a sequence of file descriptors. And also the compaction. So compaction is basically getting these small files. You can apply whatever strategy you want. For instance, right now we apply the bin packing strategy. So we grab files into a min-max value of the size, and we write them into a bigger one. And this compact is mostly the same on the index. Index manager will have data around, metadata management will need an schema and a file descriptor as well, because this file descriptor later will be committed into the log. And how, okay, that's for like mainly writing, no, we have seen, but how is the index then saved or stored? So we have, the index is stored in the files. So each file will belong to a certain part of the index, but the metadata for the index is stored in the commit log. And in this commit log, we can rebuild, we can snapshot of this commit log and retrieve in an isolation level the snapshot of how the table is looking like at certain point in the time in time. So for retrieving this information and to make a Qbeast snapshot, because there could be like different snapshot implementation depending on the format that you're using, we will have this interface that is called Qbeast snapshot. So Qbeast snapshot, what can it bring to us? We can say if it's an issue or not, if someone has written it before. We can load the latest index status. So the index status will be the index snapshot at this point in time, the latest one, so the more updated one. We can load also an index status of a specific revision ID. We can load all the revisions. We can get, not in the revision, we don't only get the ID of the revision, we get also the metadata from the revision, so we know which space has been indexed, and so on, so forth. Load the latest revision available, load the revision, and load the revision at a certain timestamp. So this is useful for retrieving information to do like time travel queries. Okay, so that's mainly on the interface, main interfaces of Qbeast. How are those interfaces used on the code that's more cooler? So what we have, let's just close the Qbeast core package, okay, and let's go to the main Qbeast Spark project. It's also in Scala, and we will go to the main point of entry when you want to interact with the format, which is indexed table. Let me find it. Okay, we have like a Spark package inside the Qbeast Spark to make it more fine-grained. Okay. okay, there's indexed table. That's one big main class. And we also have, let me find it, Qbeast data source. If I know how to write. Okay, the Qbeast data source, here it is. Okay, so Qbeast, this is more specific about Spark, but this is how you make Qbeast available for a Spark writing. So if you want to write with a Spark, you will do something like that. Let me also find some quick test. Spark integration test. This is how you write. Now with Spark, you put the data frame. You can also do it with SQL. You can put your data frame. You can write with the format that it's Qbeast and the options that are columns to index ID, and you will save in the attempt. So this code will be calling this Qbeast data source class. This Qbeast data source class will actually like create the relation and wherever, so we change the mode, and we'll write this information through the different components that we just mentioned in the Qbeast core package. So let's get a little bit more insights of the write process. So get indexed table, we check the mode, and we call table save. So this indexed table around here. This indexed table save method will check if exists. If exists, it will like load the different the latest index status, and this if this index status had a revision that you can match with the new data that you are writing it down, we don't need to create another one. But if it does, then again we need to create a new revision, so it will be a different self-contained index. Okay, then we go to the write method, and we have here like two main layers of transaction. First one, we have the keeper transaction. So the keeper is a process that is like checking up and understanding the structure of the index and noticing which cubes are being written, which tables are being written, and so on. So we can do like 2 tries of writing, because you know that in AC transactions means that the atomicity, it's like if there's 2 transactions at the same time, one will fail and one will concur, and the atomicity is that a transaction, it happens or it does not change anything in the system. So we have 2 layers of transaction here. We have the keeper layer of transaction that it gets you retry one more time if something had happened, because we can check if actually these changes will make like a super ugly effect on the index, or if you can actually commit the information without having to retry all the operation again. And the other level, it's like the committing actually to the transaction log. So getting passed by the tries or whatever, we will dig more into the do write statement. So this is where the magic happens, and this is how the many components get together. So first of all, we have the metadata manager here. This metadata manager will update the table with a transaction. It has this method here, and within this transaction of the metadata manager, we will have the index manager indexing the data, and the data writer writing the data, and then the metadata manager will commit the information. So this is where the magic happens. And what are those implementations? It can be different for any technology that you are using. Let's see what are those implementations for Delta and Spark. So let's go first on the index manager. So index manager is Spark. It's called Spark 03. O3 Manager, you can access which objects are which specific objects are instantiated through the Qbeast config, Qbeast context, Qbeast config, whatever. Qbeast context will have like the different definitions, because it extends this Qbeast core context that we have seen at the very beginning of the video. So we have a Spark, here we have a Spark Delta data writer, Spark Delta metadata manager. These are like default parameters, and a Spark O3 manager. That's what I'm gonna look into right now. So Spark O3 manager, we have three methods, which is indexing, optimizing, and analyzing. Maybe it's not the right order, okay? It's indexing, analyzing, and optimizing. So indexing is basically each record will belong to this cube. This cube is the region of the space. This record will belong to this cube. We add the metadata to each record, and we organize, like we specified each record, and we index each record in the end. Analyze will be more for finding the cubes that need an optimization, and optimization will be replicating this information in the nodes below. Why so? Because when the nodes or the cubes start being full, this information you can replicate into the children, so you can just skip cubes that are replicated and actually access to more fine-grained records of your data. So if you're doing a lot of filtering on this data, you will be benefiting from this replication. Where am I? Okay, so we have this Spark O3 manager that calls this index method here. And this index method, it's characterized for an algorithm implementation of the analyzer or indexer, let's call it. So first of all, we're gonna put everything on the weighted data frame. The weighted data frame will contain all the metadata we contain different columns with metadata of these records. And also we have this table changes case class, which is basically a container for all the information of all the metadata information that has changed. So for instance, we save the metadata. So we have, each file will belong to a cube. Its record will belong to a cube. This cube will have a max weight, which is the percentage of the data it contains. So this table changes will have a summary of this cube and max weight structure in a map. So we have a different, we will have different cubes and different weights for each of the cubes. The cubes are, I did not mention it before. The cubes are structured in a tree. So there's parents and children and so on. And we have to make another video for the cubes. So don't worry. Maybe I'm getting into more detail, but please let me know in the comments if you want some more specific videos about something. So these table changes will contain summary of table changes, basically, and index changes. Then when we have this analyzed, so we have an estimation of the index, we will index actually the records. And once we have indexed the records, we will transform based on this point weight indexer. We know how to index, more or less. With not much detail, but we know that we are getting a data frame with a certain metadata and table changes that we later on process and merge with all table changes. So what does the data writer right now? Because we index it, now it's time to write this information. So we have a data frame with different columns that says, hey, this records belongs to this group, blah blah blah. So we have to group these records into one single file. And how to do so? This is the data writer problem. So we go to Spark data writer Spark Delta data writer, because we can have like different, this is probably gonna change because we can like also separate or decouple the way we write from the actual format underlying. But right now it's like that because we output file actions, file descriptors properly, that it's specific for Delta. So we instantiate this block writer. This block writer will actually go through every partition of the data that we make partitions that it's cube and cube and everything, and each partition will have like different cubes within. And this block writer will take these records and actually writing it down to a single Parquet file. Okay, we do it like that, and we output the sequence of files that are written with the metadata from Qbeast. So for instance, if you go to the block writer, you will see here that this is the returning file descriptor, this add file. So this is a file descriptor that just said, hey, I added this file, and on the comment log you will find like adding files and deleting files. So on the tag section of this add file, we will find the necessary information for Qbeast to later on build this snapshot and understanding the index and understanding how you can filter those files. So once we have these records, these files written down, they are not yet available for each reader. Even if they are physically on the object storage, they will not, the readers will not see it because the information was not committed yet. So this is the responsibility of the metadata manager, that it's called Spark Delta Metadata Manager. We have seen that. And it's basically it's called like write with transaction. It instantiates a Delta metadata writer, and this Delta metadata writer has this method which is write with transaction. And this write with transaction is basically committing the information with this class that is an optimistic transaction. That an optimistic transaction, it's basically it happens or it does not happen. So this is mainly the process for writing. And how can we read those files? So how can we filter those files from the log? So for that, it's kind of a bit of tricky and complex for the Spark point of view. But we're gonna like just see a single class. Well, let's do one thing. Let's go to the load part of the Qbeast data source. So Qbeast data source will have this well, let's get more into example, no? So this is how we write, and this is how we read. Okay, Spark read format in Qbeast and load from that path. So the load operation, it will happen here. It will be redirected to the create relation, and this create relation will load the existing table. Okay, this load will have on the indexed table. Okay, this load implementation will create a Qbeast relation. The Qbeast base relation or base relation, it's something that Spark plans understand to actually, it's like the last step of the plan, the data source, the base relation, the what is underlying. So this base relation, it is, oh my god, a lot of layers, maybe it can be optimized, of course. So this base relation, it's built here. It's in the create relation and the Qbeast base relation. this create relation will actually output a Hadoop FS relation, so a file system relation, that it's basically a file system data source with a certain file index. This certain file index will be queried with the filters that someone applied on the data. So this one, no, we want to filter people from Barcelona and with age greater than 20. So these filters will be redirected to some methods of the file index. And this file index is an O3 index. It's an own index. And this O3 index has different methods that we're going to see. This O3 index has, here it's where the magic happens, no? List files. So, hey, once we have translated the query from the user and we know what he wants to know, we will pass those filters, we will push down those filters to the data source, because data sources know how to filter data before processing it, and we're gonna let them do their thing. So that's how Qbeast behaves, okay? We have this, we will receive some partition filters and some data filters. Since we didn't partition the data, so we avoid traditional partitioning, we don't care really about each one of them separately. We will put them together. And those matching blocks, these matching blocks a method, it will retrieve, it will create like the snapshot, it will filter from the snapshot and return the Qbeast blocks or the files that you have to read, okay, or that Spark has to read, sorry. We have two different classes here. We have the query spec builder, like you give me those filters and I will like create a query spec that Qbeast can understand. And the query executor, that it's giving me that query spec and give me that snapshot of the index. I will search within those cubes and will retrieve which files from these cubes you will need to answer the query. And I think that's pretty much a lot of information right now. It's almost 32 minutes, me talking alone. I know there's a lot here, but I think I kind of like summarize each of the like main components of the project. Of course, we will need to get more videos of this. I will try to make more self-contained videos, so not super all-in-one recordings. And of course, if you are interested on a certain part or you didn't understand quite well maybe the index manager or the O3 index or whatever, please just write me on comments here on YouTube channel, comments on the Slack, comments even on GitHub. I don't know, GitHub in any pull requests, and I will be like super glad of clarifying any doubt, because I think it's important to help people out when they face these super complex projects. And I know a lot about these projects, so please don't hesitate. And if something doesn't really kind of gets in the like you didn't understand or it doesn't sound good, please reach out. We'll be super glad to start a conversation around it. Yeah, that's basically it. Hope that you enjoyed the video. Please, the GitHub page, give us a star if you like the project. Don't hesitate to talk to me on Slack for any possible collaboration or doubts. And see you on next videos. Bye.